Now let us study the test-driven development. In the case of test-driven development, it is a interleave testing, and it means in between that testing that it has been done, code and the code development, there it is going to get tested. Interleave means interleave testing and code development. So here what happens basically is the test is getting executed for the code. So if there's an integration is there for the two systems or two programs, both programs that has been tested, and data is being passed from one program to another program. Okay, parameters to getting passed. Those things are going to get checked properly. Okay, and the criticality of the system. Okay, so the criticality of the system is nothing but whenever that input set is being given, okay, you're not going to get the proper output. So it is a criticality. It is okay. So why you'll be not going to get the test is being done in that. Then incrementally that you have to raise the inputs. So if your system is going to take approximately 100 inputs, so you have to step by step you should make it, that is 10, 20, 30, like that you should increase the number of inputs. So once if it reaches 100, if it accepts, it's okay. 110 if you want to say, instead of saying 110, you should start with 101. If it accepts, then it is wrong. Okay, because the maximum capacity of accepting of that particular system is 100 only, 100 inputs. So more than that it cannot accept it. That testing is going to be made. It is the stress testing. It is going to be. It's going to be stress testing. Usually this is done for the plan-driven development. Test-driven development, here it is going to check for the individual functionalities. Okay, identify the functionalities, new functions if it is going to be added. Then for that you have to write the test cases, run the test case. Whether it passes the test case or fails the test case, that you have to check it. If it fails the test case, again implement the functionality once again. Then again you should rerun the test. Then you should check for the pass or fail. If it passes, okay, again go back to the new functionality. Write one more functionality and again rerun the test. Okay, write the test cases, rerun the test. This is what the test-driven development. What are the benefits of this test-driven development? The code coverage. All the codes have been getting executed. Okay, from start to the end, all the codes have been tested. Regression testing. It is incrementally that whenever that we are doing it. So all the programs have been properly, it is getting covered. So regression testing is being done for the complete system. Simplified debugging. If any faults are there, if any failures are there in that, then you should observe that particular failure, which program that fails that. Those things you have to be checked and you have to modify that particular system and again rerun it. Then system documentation, where when you go do the testing, documentation is very, very important thing. How many programs that should be tested and it is passed, all these coding systems and all these things, that it should be made documentation, so that rerunning of that particular code is getting avoided. Again, when we say that regression test, so it checks for the changes not broken previously working code. Means continuously the program is getting checked. Okay, it should not be broken down. Means once I am going to test this one, next time I am going to test, not like that. Complete thing that you will be going to test it. Okay, and sometimes you will be going to test manually also. So regressive testing is exhaustive testing. It is going to be where a number of times that you will be going to make it in the straightforward way that you are going to test that particular program with the time. Then the test is going to be successful when it doesn't have any changes in the program. Okay, then only we can say that regression test is passed.